Hello, my name is Dora and I'm from the Belgian Anti-Doping Laboratory, and my topic centers around a research article that we recently got published. Now, when you look at the adverse analytical findings and the top 5 categories that are involved in them, you can see that the anabolic agents are still used heavily by the professional athletes, and so we need to maintain our efforts to improve their detection, whether it is developing more sensitive methods or finding new long-term metabolites. Now, as such, evidence has shown for the past 10 years that an extended detection time can actually be provided by the sulfated metabolites. However, they are deemed incompatible with the current setup. So ideally, one would want to include them without needing to analyze them in a separate method, as that is not economically feasible for the anti-doping laboratories. And so we developed an initial testing procedure on GC-MS that includes 3 classes of metabolites, as well as compounds from 9 different categories on the prohibited list, as well as the quantification of the endogenous steroids. Now, why? Well, we need to try and make full use of what is available to us so that we can maximize our chances to detect doping. And as for the outline, first I want to show you how this was accomplished, how well the method performs, and thirdly, the results of our evaluation of the procedure using excretion studies. But first, how was this accomplished? Now, the instrumentation that we use, it has the capability of using soft ionization that induces larger mass fragments, and therefore it has increased sensitivity. For the detector, it is run in a full scan mode, and therefore we can include virtually unlimited number of compounds. As for the sample procedure, it is a combination of 2 different liquid-liquid extractions. And as we also include the quantification of the endogenous steroids, we are required to include a hydrolysis in this procedure that we refer to as the combined sample preparation. So also, when we were determining the lower limit of detection, we decided to only spec the vial intended for hydrolysis with the reference standards, as their availability is mainly in the non-conjugated form. However, this means that actually for compounds that are excreted free, it is actually an underestimation of the method's capabilities. So for the validation, I want to show you 2 results. First is the quantification of the endogenous steroids, and that it is not negatively affected, is actually quite accurate, where the majority of the values are below 1 on the Z-score. And for the distribution of the lower limit of detection, you can see that for the bulk of the results, we are actually below the required, the half mmol, which is the minimum requirement. So when evaluating the procedure, we decided to use excretion studies to try to simulate a real-life scenario, and we chose 3 steroids with 2 individuals in each time, and used the samples where we extracted them with the 2 sample procedures. And looking at the detection time of the conventional metabolites, you can see that there's no difference between the 2, except in one case. However, when looking at the detection time of the sulfated metabolites, you can see that they extend the detection time, so they counteract that drawback. So, to conclude, to be able to include the sulfated metabolites in the initial testing procedure, we used an instrument that is capable of including as many compounds as we wanted, and also we used a sample procedure that is capable of extracting 3 classes of metabolites. The method is fully validated and has no negative effect on the quantification of the endogenous steroids, and for the majority of the LLODs, we are below the required half mmol. And lastly, when running excretion studies, we found little to no effect on the conventional metabolites. And in 2 of the 3 anabolics that we studied, it actually provided an extended detection time. And so we can say that you can now make full use of what is available to you, so that we all can now maximize our chances to detect doping. Now, I would like to thank my co-authors and my colleagues here at DoCoLab. I would also like to thank PCC for their funding and this opportunity to present my research here today, and thank you for your attention.